Welcome to GATE Academy. This is the introduction video of digital electronics and microprocessor. So in this video, I will explain you what all topics I have covered and in what particular sequence so that you can plan accordingly. I will suggest you should go as per my sequence only. I have planned very nicely for you in a very systematic way, and I am sure you are going to enjoy this complete video course. At proper places, I have placed numericals so that just after understanding a concept, you can practice numericals on them. And at the end of each chapter, I have given some additional practice questions for you. So the first chapter that I will be starting will be logic gates. In logic gates, first we will discuss that there are three types of logic gates: basic gates, universal gates and special purpose gates. In universal gates, we will be discussing how to design a given function using minimum number of universal gates, that will be NAND gate or NOR gate. We will also be discussing about the switching circuit representation of all the gates. Then there comes a special case in designing using minimum number of universal gates, that is, we have to design XOR gate and XNOR gate using minimum number of universal gates. This comes under a special case. That special case I will be discussing. Then what is the propagation delay in a logic gate, that we will be discussing in detail, and we will be solving all the questions which have come in the GATE exam. And at the end we will be discussing ring oscillator. So this will complete the topic logic gates. Okay. Now moving ahead, the next chapter will be Boolean algebra. So in Boolean algebra, first of all, we will be discussing the basic laws of Boolean algebra and how to minimize a particular given function using Boolean algebra. There are two different ways to minimize any Boolean function. One is using the laws of Boolean algebra. Second one is K-maps, that we will be learning in chapter number 3. So in this, we will be solving or minimizing the question using laws of Boolean algebra. We will cover all the laws, including associative law, consensus law, principle of duality, De Morgan's, all the laws we will discuss. Then we will discuss how to find maximum number of unique Boolean function for any number of variables. I said how to find, so we will just not concentrate on the answer, but also how you can find this number. Then this is the most important part of complete digital electronics, you can say, that is the SOP and POS. So in very detail we will be discussing SOP and POS, as from this point this will be used till the end of the sequential circuit. In whatever Boolean algebra we are solving, we will need SOP and POS. In any combinational circuit we are studying, we will be using SOP and POS. In all the sequential circuit topics, we will be discussing SOP and POS. You can say this is heart of your digital electronics. You should be very good in SOP and POS with 0% of confusion. Next, we will be discussing what will happen if you pass two functions through a logic gate. For example, AND gate will pass only the common min terms, OR gate will pass all the terms. So like this, what NOT gate will affect. So all these type of discussions we will be doing in Boolean algebra. So you must be seeing in a very systematic way. I have planned everything for you. Just follow this sequence and you are going to love this subject. Next will be chapter 3, K-maps. So K-maps, initially I will be explaining you how does a K-map works. We all of us know how to plot K-map, how to extract minimum expression for K-map, but exactly how the minimization happens, that also I have tried to explain you in the K-maps so that you can have the complete knowledge. In K-maps, we will be discussing 2 variable, 3 variable, 4 variable and 5 variable K-map, and very important in POS format as well. In university, maybe you must have concentrated on SOP, but for GATE exam, you need to concentrate on POS as well. So equal importance we will be giving for POS K-maps as well. In don't care terms, see, it is very simple that how do you solve the questions of don't care, but I have tried to justify how does that minimization happen, or you can say significance of don't care terms I have tried to justify in my video course. Next, very important topic, prime implicant and essential prime implicants. This topic we will be studying with the help of K-maps. So this chapter is again very important. So you can see all these topics are very basic, and I will suggest you do not skip any topic. However good you are, just maintain this sequence and you will, I am saying, you will definitely love the subject digital electronics. Next, chapter 4, we will see number system, binary codes and complement forms. So let us see what we have in this unit. So first we will be starting with number system and conversion. So we will be discussing the basic number system we have and how to convert a number from one number system to another number system. We will discuss it so systematically that we will be able to solve the question for any base number system. Next, we will be discussing BCD codes, all the types of BCD codes, self-complementing, etc., all the types of BCD codes, and we will also be discussing Gray code. Sign magnitude form, ones complement and twos complement representation we are going to discuss for a binary number. Then also how to find the twos complement shortcut method. And finally, very important topic, the concept of overflow. This I will be discussing in very much detail. So after this unit, next we will be starting with combinational circuits. So in combinational circuit, we will be starting with the most important combinational circuit with respect to GATE exam, that which is multiplexer. In multiplexer, we will be discussing in detail how to design a multiplexer, how to design a function using multiplexer, how to find out the output of a multiplexer, all the possible size of multiplexer, 2x1, 4x1, 8x1, etc. Then we also, next we will be discussing multiplexer with enable inputs. So in detail we will be discussing about enable input, because this enable input can be given in any of the combinational circuit. Next, as I said, we will be learning how to design any function using multiplexer. It means we will justify multiplexer as a universal circuit. Then next one is how to design a higher order multiplexer using a lower order multiplexer. Then we will be discussing demultiplexer. Demultiplexer we don't have to study in so much of the detail as we study multiplexer. In short only we have to cover this. Decoder we have to discuss in detail. Also active low output decoders as well. So all the types of decoder, all the possibilities in detail I will discuss. Encoder and especially priority encoder in detail I will be discussing. Why do we need a priority encoder and all the things. Then adders and subtractors, which will contain half adder, half subtractor, full adder, full subtractor, binary parallel adder, look ahead carry adder, all the questions based on delay which have been asked in binary parallel adder. There are so many questions and very conceptual questions. All those questions I will be discussing. Next we will be discussing comparator. Next, code converter, for example binary to gray or gray to binary, or BCD to XS3, XS3 to 8421, any sort of codes. Then at last we will be discussing about programmable logic devices. In this we will study PLA, PLs and programmable ROMs. So this will complete your combinational circuit. So you can see I will be dealing with all the types of possible combinational, all the possible type of combinational circuit, all the possible types of questions, whatever have been asked till date in GATE exam. Next, chapter 6, sequential circuit, the most important and the most conceptual topic of digital electronics. We will be starting from the very basic, how a sequential circuit is different from a combinational circuit, what are the differences, and then we will be starting with the memory element. So first we will be discussing latch and then we will be going to flip-flop. In latch we will be discussing both NOR gate and NAND gate. Very very interesting discussion I will do here between the SR latch of the NOR gate and the NAND gate. I will justify you both of them are functionally equivalent. It is just the matter of representation of two different forms. So you are going to have a very interesting discussion over this topic. Then we will be starting with flip-flop. In flip-flop, we will be studying all the four standard flip-flop SR, D, JK and T. In flip-flop, we are going to start from the circuit. Then we are going to discuss the truth table, the characteristics table, characteristics equation. Characteristics equation is also called as next state equation, and excitation table at the last. In circuit, we will be discussing both using NOR gate and using NAND gate. Next, after studying all the flip-flop, we will discuss a very generalized way of flip-flop conversion. Next, we will be starting with synchronous counter. So, synchronous counter, first we will study how to design a synchronous counter from the next state equation or the state table or the state diagram. Okay. Next, after learning designing of synchronous counter, we will try to analyze the synchronous counter. Let's say if a synchronous counter design or circuit is given, what will be the state table or what will be the state diagram, what will be the sequence of states. So all the things including designing and analysis. Now the next version of synchronous counter that contains external input, very important with respect to GATE exam. With a very important example, I will be considering up-down counter. So with that example, I will be discussing what is an external input in a synchronous counter. Then I will be discussing alternative way to approach the alternative approach for solving the question of synchronous counter, because questions of different types can ask solution in a different way. So I will try to tell you all the possibilities. It will be up to you in what type you want to solve in the GATE exam, but I am going to explore all the possibilities in front of you. Next, edge triggered and level triggered flip-flop. What is the difference, positive, negative, all the things in detail we are going to discuss, so that we can study asynchronous counter, because all these things will be required to understand the concept of asynchronous counter. In asynchronous counter also there are a lot of things. So first we will discuss, after discussing how to design asynchronous counter or the concept of asynchronous, we will be discussing how to design up and down counter, what are the differences in the steps of the designing. Then mod n counter means how to change the mod value, how to change mod 8 into mod 6, etc., how to change mod 16 into mod 10, etc. All these things. How does the frequency division happens in asynchronous counter? What is synchronous clear and preset input in asynchronous counter? So all these things in asynchronous counter we are going to discuss. Then we will compare the delay of synchronous and asynchronous counter. There are a lot of differences and questions are being asked from this topic as well. Then very important, self-starting counter we will discuss. Then cascading of counter. So you can see I am not going to leave any topic. All the things you are going to have in lot of details. Next, self-starting, we are also going to have cascading. Then race around condition and master slave flip-flop, which is again a very important discussion. Shift register and all the applications, counter, Johnson counter, etc. And at last, even we are going to discuss the concept of setup time and hold time with the help of the questions that have come in the GATE exam. So you can see I am not going to leave any topic in any of the unit. So you will have a full coverage. So just follow the sequence which we are discussing in this video, or follow the sequence which have been given to you in the complete video course, and you will feel very confident in this subject. Next chapter we will be discussing is DAC and ADC. So first I will be discussing what is a DAC, and then I will discuss what is a weighted resistor DAC. Then we will be moving to ADC. So we will discuss what is ADC and all the types of ADC, that is parallel comparator, successive approximation, counter type and dual slope ADC. We are also going to discuss all the details of full scale output voltage, resolution and step size. In ADC, we are going to discuss in detail the conversion time and the complete process, all the questions which have been asked in the GATE exam till now. So in this video, I have not mentioned ki what all questions we are going to discuss. Don't worry, we are going to discuss ample number of questions with proper placing of the questions. For example, if we have studied parallel comparator, then immediately after that, you will be seeing the questions on that parallel comparator. Let's say whenever you study dual slope ADC, immediately after the concept of dual slope ADC, we will be discussing all the questions on ADC. So in a very systematic way, I have tried to cover the complete syllabus. So just go by the sequence which I am taking. Next, at the end, first we have studied weighted resistor DAC. So there is another type of DAC that we will be discussing, is a R2R ladder type DAC, and again obviously all the questions on this particular topic as well. Next we will be discussing microprocessor 8085. So first we will be discussing the basic introduction, why microprocessor is required, what was the motivation behind the designing of microprocessor, all the basic architecture details required for the GATE examination. Next we are going to discuss instruction set, in which we are going to discuss one by one in the form of groups. So first is data transfer group, arithmetic instructions, logical, branch, logical I have already written, stack group instruction. After discussing the instruction, in this also we are going to see all the details one by one in detail, what all instructions operation is to be performed, then how much is the space required to store an instruction in the microprocessor, and all the details. So in this we are going to discuss about the spacing also, how much bytes of instruction it is. Then immediately next we are going to discuss the timing issues. How much time a particular instruction takes, or how much time a program will take for the complete execution, which we will discuss in the topic T states, machine cycle and instruction cycle. Obviously this also again we are going to study in detail how to count time of any instruction or the complete program. Then interrupts also we are going to discuss. Then very important topic, memory and memory interfacing. So if you interface a particular size of memory with the processor, what will be the first address, what will be the last address, all these type of questions. So just don't worry for everything, whatever is required for your coming GATE exam, all the things I have covered in this complete video course. Next we are going to discuss logic family. So logic families, RTL and DTL we are going to start with, and then we are going to discuss the CMOS. Although it is very easy topic, but still we will discuss in detail with all the possible questions that have again come in the GATE exam. This part of the video I am specially making for electrical engineering students. See, this subject, digital electronics and microprocessor, although it is common for electronics, instrumentation and electrical students, still there is a big difference in these branches. For electronics and instrumentation, it is like a core subject with a very high weightage. In electrical engineering, the weightage is a bit less as compared to electronics or instrumentation. So electronics and instrumentation students have to study the complete syllabus, which I will be doing in this video course. Electrical students may skip some of the topic if time left for them is less. As they have a very vast syllabus of electrical engineering, if you are facing issue of a time, you can skip some of the topics. For example, which topics you can very comfortably skip without any risk is number system will not be asked in GATE exam of electrical engineering. Remember, I am using the word it will not be asked in GATE exam. Okay, so if you are targeting EAC exam, you cannot skip this one. So for GATE electrical syllabus, you can ignore number system comfortably. You can ignore the complement form. So these two topics you can ignore. So these are the topics with less preference I have written. In binary code, you can just study some basic information about the BCD codes. Just some basic information about BCD codes. If you study, this will be sufficient. You can ignore this complete chapter number 4. See, chapter number 1, 2 and 3. Logic gates, Boolean algebra and K-maps, nothing you can skip. You have to study in detail all the 3 chapters 1, 2 and 3. In 4th, you can almost ignore the complete unit except for some basic information about BCD codes. So, you can ignore number system, you can ignore complement form. It means these 2 topics you can ignore along with complement form means 1's complement, 2's complement. So, even you can ignore the overflow part. What I am saying, almost the complete unit you can ignore except a small information about BCD code. Now, this you can comfortably skip. What topics again you can very comfortably skip? I am telling that first, and then I will be discussing the less important topics. So, next what you can completely ignore is this programmable logic devices. Programmable logic devices you can completely ignore. This is for electronics and instrumentation only. And in logic family, or I should say, you can ignore the complete unit of logic family, because for electronics and instrumentation they may be asked with the question of CMOS logic family. You guys will not be asked for this unit questions. Now, so what you can very comfortably skip: number system, complement form and CMOS logic family and programmable logic devices. Till now, whatever topics I have told you, you can ignore very comfortably. Now, coming to the less important topics, see, less important topic means, see, in multiplexer, we will discuss 2 things, analysis and designing. Analysis means multiplexer is given, you need to find the output. Designing means function will be given, you need to design it using a multiplexer. So, doubly guys, you have to mainly focus on analysis of a multiplexer rather than designing of a multiplexer. So, this part you can give less importance. Now, there are few delay questions on adders, especially binary parallel adders. You can say those are of advanced level. Those type of specific questions you can skip. Then, in sequential circuit, you may skip, I am saying you may skip. See, if you have time, you should cover these also, but just I am saying for those guys who will be starting a bit late, and if there is a time constraint with respect to this subject, electrical engineering, what they can give less importance to, that is what I am discussing here. So, synchronous counter with external input, this topic, which will cover alternative approach, which I will be discussing in the name of alternative approach in the videos. Synchronous clear and preset input. Most of the miscellaneous questions in, I have given this as the topic name only, miscellaneous questions. You will find it in index also easily. Just search miscellaneous questions. And setup time and hold time. This is also which you can ignore very comfortably, setup time and hold time. So, starting with the very least importance, almost out of the syllabus, not in GATE syllabus, number system, complement form, programmable logic devices, CMOS and setup time and hold time, which I have cut, which I have given a big cut. This is almost you can ignore very comfortably. You can say this is out of the GATE electrical syllabus. Other topics which I have written but not cross-marked, they are somewhat less important, which you may ignore in your phases. If you require any more details, I will always be available to you. You can approach me on Messenger and you can ask questions on a Facebook secret group. We will be happy to answer your queries. Any question means even a technical question or something related to the preparation, what you should do, what you should not do, especially for electrical engineering, because for them total syllabus is vast and sometimes there may be requirement to just study some less topics in digital electronics. So with respect to that also, I will be happy to help you. So this is all the details about the syllabus. If you have any more concern, you can contact me. I will be happy to help you.